Hello everyone, welcome to this very first lecture of optical instrumentation. My name is Sharad Gupta, and in this lecture we will discuss about this course, and then we will discuss about certain fundamental facts about light. Okay. So, the name of this course is Optical Instrumentation. So, this name is made by joining two words, one is optics and another is instrumentation. So, what is optics? It is a branch of physics that studies the behavior and properties of light. Okay. In your earlier classes and also in your 11th and 12th schooling, we all have studied optics in physics. Okay. So, we all are very much familiar with this word optics. So, it is that branch of physics in which we study about light, its properties, its behavior, including its interaction with matter and the construction of instruments that use or detect it. Okay. So, this is a branch of physics that deals with the study and the instruments of light. Next is optical instrumentation. So, instrumentation, it is a branch of engineering. It is a branch of engineering that mainly deals with measurement and monitoring of physical quantities. Okay. So, in this course we will study the nature, emission, propagation of light, generation and detection of light. Also, we will discuss different applications related to sensing and measurement of light. So, mainly we will discuss certain properties of light, how to measure those properties, instruments that are used to measure those properties, and how to use those properties to measure different things. So, this is optical instrumentation, light and the measurement that is related with light. Okay. So, in this course, first topic that we will discuss is certain fundamental facts about light. You all must be already familiar with these fundamental facts, but we will make a quick revision about these fundamental facts. Okay. So, first fundamental fact we all know, light passes through vacuum. How do we know that light passes through vacuum? Because there is a huge amount of vacuum between sun and earth. There is a huge free space between different stars and earth. So, light passes through all that space and it reaches to us on earth from sun, from stars. So, this is the fundamental fact about light, that it passes through vacuum. Second, so light passes through vacuum. Second, in a homogeneous medium, light travels in a straight line. Okay? Like air is a homogeneous medium or any glass is a homogeneous medium. So, light travels in a straight line. We have already done experiments on this in our schooling in 10+2 classes. Okay. Light is reflected by a smooth surface. Okay. Light is reflected, this is how we see things, because light is reflected from various surfaces. Light is refracted at the surface separating two transparent media. Okay. So, when light travels from one medium to another medium, it slightly bends from its straight line. Okay. And this is called refraction. It bends on the surface that separates two medium, two transparent medium. We will discuss these fundamental facts in little bit more details. Another fundamental fact, white light passing through a prism is dispersed in a number of colors. Okay. When we pass a light ray a white light ray from a prism, then it is divided into 7 different colors and we get a Vibgyor pattern, right. So, in a homogeneous medium, light travels in a straight line, it is reflected, it is refracted, it is dispersed, it is called dispersion. Another fundamental fact, we know what is the velocity of light. Light travels with a velocity of about 3 into 10 to the power 5 meter per second. Okay. Three into 10 to the power 8 meter per second. It is 3 into 10 to the power 5 kilometers per second or 3 into 10 to the power 8 meters per second. The velocity of light in a denser medium is less and its velocity in rarer medium is more, okay. Like in air and in water, if we compare the velocity of light in air and water, then the velocity of light is more in air and its velocity is less in water. Similarly, velocity of light in vacuum is more and in air it is less. Like this is the velocity of light in vacuum, 3 into 10 to the power 8 meters per second. It depends on the refractive index of that medium. If refractive index is more, then velocity is less, okay. This is also a fundamental fact that we already know through different experiments. These things are already proven. Light bends around the corners of small obstacles and apertures. This is called diffraction. So, light also undergoes diffraction. It bends round the sharp corners. Fine. Next, light rays show interference. If two light rays travelling in a same medium, they interfere with each other, and if they are from same source, then we get a interference pattern, okay. It is used in various applications for various measurements and studies. Also, polarization of light. Light undergoes polarization when it is passed through certain crystals. This we already know, we have already studied these things. Total internal reflection and double refraction. So, these are certain well known facts that we have already discussed in our earlier, in our schooling classes, schooling subjects, okay. We will discuss these things a little bit more detail. And the last fundamental fact is light exerts pressure. When light ray falls on certain material at perpendicular direction at 90-degree angle, then they exert certain pressure. It is very less, we cannot feel it, but it can be measured using certain instruments. So, light exerts pressure. So, these are the well known fundamental facts that are already proven or we know. We will discuss these in little bit more detail in following slides, okay. So, first is reflection. How reflection is explained in school classes, in small classes like second, third, fourth, like this. Using a mirror, we can reflect light. Light is reflected from smooth surfaces. How do we see different objects? How do we take pictures of different objects? Because the light ray that are reflected by different surfaces, they fall on the retina of our eyes, they are focused on the retina of our eyes, and our brain, the sensors on the retina, they read those reflected light beams, okay. Similarly, how do we take pictures from cameras? The light ray that are being reflected from different surfaces, they are focused on sensor array or on photographic film, and their colors, their intensities are recorded, and then we can regenerate them in lab or on digital screen. Okay. So, it is due to this phenomena of reflection that we all can see different things in different colors. Okay. When light ray is reflected from any surface, some of the colors are absorbed and few are reflected back. So, this is how we see things colorful. If we see a green surface like in this picture, this lady is seeing a tree. So, this is green in color. Why? Because these leaves are reflecting green color. Okay. And this stem is reflecting brown color. So, we can see due to reflection. There are certain examples of reflection from a smooth surface, and this is diffuse reflection because the surface is not smooth. Fine. We also studied two laws of reflection. What were those? First law is the light, the incident ray, the reflected ray and the normal to the surface of the mirror all lie in the same plane. The ray that is incident, then this is the smooth surface, this is reflected ray, this ray is reflected from this smooth surface, maybe this is a mirror or maybe some other smooth surface, and this is normal. All these three things we consider them to be lying in a single plane. Okay. They lie in the same plane. This is first law of reflection. Second law, the angle of incidence is equal to the angle of reflection. Angle of incidence I is equal to angle of reflection R. Okay. Next, refraction. So, bending of light rays at the separating surface of two mediums. So, this is one example. If we put a pencil in a half filled glass of water, then how do we see the pencil? Look at this. Like if this is broken at the surface, but it is not broken. The light rays are bending at the surface. This is one way. Another example over here, there is a fish in water, this is air, this is water, and there is a viewer. Okay. So, light ray that is reflected from the fish, it will refract at this surface and it will bend away from the normal, Why? Because light ray is coming from denser medium to rarer medium, and this we know, when light enters from a denser medium to rarer medium, then it bends away from the normal. Okay. So, it is bending away from the normal, and if there is a person standing over here and he is seeing the fish, then he will think that the fish is here. Okay. It looks like fish is here, but actual position of the fish is this. Why? Because it is due to refraction, because light rays bend at the separating surface of two medium. This is the image, it is taken from Wikipedia. This is a rectangular glass sheet and a light ray is coming over here. So, look, it is bending towards the normal and then it is bending away from the normal, right. Where is normal? If we draw normal here, this is normal. So, rarer to denser, it is bending towards the normal, and when denser to rarer, it is bending away from the normal. Okay. So, this is refraction. There are also two laws of refraction. The incident ray, the refracted ray, and the normal to the interface of any two given mediums all lie in the same plane. Okay. The ratio of the sine of the angle of the incidence and the sine of the angle of the refraction is constant. So, this angle divided by this angle is a constant. Okay. So, this is medium 1 with refractive index n1, this is medium 2 with refractive index n2, this is normal. So, light ray is entering from a rarer medium to a denser medium. So, it is bending towards the normal. This is angle of incidence, this is angle of refraction, and their ratio is a constant. And what is the constant? Sine theta 1 divided by sine theta 2 is equal to n2 divided by n1. Okay. The ratio of the refractive indexes of medium 2 divided by the refractive index of medium 1. So, these are two laws of refraction. We have already, this is a revision, we have already studied this in our school days. Now, dispersion. Next is dispersion. What is dispersion? When we pass a white light ray through a prism, it is divided into 7 colors. Okay. So, like here, this is a prism and white light is coming through a slit, it will be divided into 7 colors. We know what are the 7 colors. We get a whipjaw pattern: violet, blue, green, violet, indigo, blue, green, yellow, orange, red. Okay. And this is another image of a prism, actual image taken, and this is how we see rainbows. When there are water droplets, they divide these the white light into 7 different colors. Okay. So, this is dispersion. Next is diffraction. So, diffraction is bending of light rays around the sharp corners. Now, we know light always travels in a straight line, and it, from refraction we have seen that it bends at the separation medium of two surfaces. But light ray can also bend around the sharp corners like this. You see, this is a cloud, light ray is coming from the sun, and how do we see it? Like they are spreading. Why it is spreading? Due to diffraction, because over here this is a source of light, this is a opaque thing, and light ray is coming, a ray of light is coming. So, it does not come straight, it slightly bends in the shadow area, and this is called diffraction. Another example is, there is a monochromatic light source, laser, and there is a narrow slit over here. It is a very narrow slit. A parallel wavefront is coming on that slit. So, if light ray always travel in a straight line, then how do we get? Like this. But we do not get like this. Light is diffracted, bending of light rays round the sharp corners. This is called diffraction, and there is a condition. The size of the slit or the size of the particle should be comparable with the wavelength of light. If the size is very high, high with comparison to the wavelength of light, then diffraction, we do not get diffraction pattern. Okay. So, if the size of this slit or the size of the particles is comparable with the wavelength of light, then it is diffracted. Like in this picture, light is getting diffracted because the slit is very small and the size of the slit is comparable with the wavelength of light. Okay. So, this is diffraction. Fine. Interference. Young's double slit experiment. You all must remember. Young's double slit experiment. This is the picture of Young's double slit experiment. So, there is a monochromatic light source and we have taken two slits, two narrow slits. So, how do they work? They work like two separate sources, coherent sources. So, two rays are coming out of those slits. So, what will happen? They will superimpose with each other, and when they superimpose with each other, the intensity of these two light rays, either it gets added or subtracted from each other. So, accordingly on the screen we get interference pattern. What do we get in interference pattern? We get bright and dark fringes, bright and dark fringes of light, where the amplitude of these of light rays from these two sources cancel each other. We get dark fringes, destructive interference, remember, and where the amplitude gets added, we get bright fringes, constructive interference it is called, constructive interference. This is how an interference pattern looks like over here. Source 1, source 2, so we get two separate sources and we get destructive and constructive interference. Over here we are getting constructive interference, destructive, destructive, constructive. So, like this we get bright and dark fringes as shown in this interference pattern, right. Polarization. We will discuss polarization in more details in the following lectures. Okay. So, what is polarization? This is how polarization is explained in school books. This image is taken from school books. So, how do they explain? Like if there is a window and the bars of window are like this, and if we move a string, then the energy, the vibrations will go and pass through the bars. But if the bars are like this, then vibrations are stopped. Okay. And again, if we have two windows back to back with vertical and horizontal bars, then if we move a string like this, then it will be passed from the first window, but the second window will stop the vibrations. Light is an electromagnetic wave, and what is the meaning of this? That there are electric and magnetic vector that vibrates in all the planes. There are certain materials, if we pass the light ray through those materials, then the vibration is confined to a single plane. This light is called plane polarized light, and the process of confining these vibrations from all the planes to a single plane is called polarization. Okay. So, we will discuss polarization in more details in the following lectures. Fine. So, this was all about the fundamental facts of light that we have discussed. In later lectures, we will discuss these facts and the theories that are related to these facts, these phenomena in more details. Basically, this course is divided into 5 modules, or you can say 5 units. In first module, we will discuss about these facts, we shall discuss about these facts and then different theories that are proposed about light. We will discuss about diffraction and diffraction grating. polarization, different kind of polarizations, double refraction, and in the last we will discuss 3 modulation schemes, electro-optic effect, magneto-optic effect and acousto-optic effect. This is module 1 or unit 1. In unit 2 we will discuss 2 kind of sources of light, one is LED, another is laser, and in second unit we will also discuss light detectors. So, light sources and light detectors, these things we will discuss in unit 2. In unit 3 we will discuss interferometers. These are the laboratory instruments that are based on interference effect, and they are extensively used in research laboratories and industries. Okay. In 4th unit we will discuss about holography and optical fiber sensors. It is an application of optical fibers that is used for measurement purpose. We all know what are optical fibers, they are mainly used for communication, but there is a use of measurement also. We will discuss it in 4th unit, and then in 5th unit we will discuss about the fundamentals of optical fibers and certain measurements that are related to optical fibers. Okay. So, this is overall topics or syllabus that we shall cover in this course. So, thank you.